morning to all. Last class we discussed about ionization energy, electron affinity and also ionic radius. Today we have to discuss about another topic, electronegativity. So what is electronegativity means? The tendency of covalent bonded atom to attract to the sharing pair of electrons towards itself. That means simple meaning, covalent bond atom it can able to attract to the electrons towards itself. Okay, this electronegativity means able to attract towards itself for covalent bonded atoms. This electronegativity depends on the effective nucleus charge and also atomic size. Okay, one atom or one element they can able to attract the electrons towards itself depends on that element effective nucleus charge and also the element atomic size. Okay, so here electronegativity directly proportional to nucleus charge. If that element having more nucleus charge means electronegativity also more, because nucleus attractions more means it can easily pull the electrons, it can easily attract the electrons from another atom. Next, electronegativity inversely proportional to atomic radius, that means atomic size. That means small atomic size means more nucleus attraction means more attract the electrons towards itself. That's why electronegativity inversely proportional to atomic size, directly proportional to nucleus charge. Okay, then how does electronegativity variation in periods and groups? Okay, in periods electronegativity from left to right increases. Why? Because in periods from left to right nucleus charge increases while atomic size decreases. That's why electronegativity from left to right increases in periods. So in periods here means electronegativity from left to right increases. Okay, due to nucleus, Nc means nucleus charge. Due to nucleus charge increases, atomic size decreases. Then in groups, generally in groups, top to bottom decreases, because in any group top to bottom nucleus charge is decreases while atomic size is increases. That's why in groups top to bottom electronegativity here means electronegativity decreases due to nucleus charge. Nc means nucleus charge decreases while atomic size increases. Okay, this is how does Remember. So fluorine highest electronegativity value 4.0, then after oxygen 3.5, nitrogen and chlorine 3.0, bromine 2.8, iodine and sulfur 2.5, phosphorus, carbon and hydrogen 2.1. These are the electronegative general values, not nothing, just idea. Okay. Then electronegativity directly proportional to positive charge, inversely proportional to negative charge, Why? Already we discussed in atomic radius topic. Positive charge elements means they can lose off electrons. That's why protons remains constant. Their nucleus charge is more. Negative charge elements means they can gain electron. They having excess of electrons. That's why their nucleus charge is less. Already we discussed in atomic radius topic. That's why electronegativity directly proportional to positive charge and negative charge means positive charge elements having more nucleus charge. Negative charge elements having less nucleus charge compared to positive charge elements. So negative charge elements having somewhat less nucleus charge. So already we know electronegativity directly proportional to nucleus charge. That's why compared to negative charge elements, positive charge elements having more nucleus charge. That's why directly proportional to electron affinity. That's why manganese 2 plus compared to manganese 2 plus, manganese 4 plus more electronegativity compared to manganese 4 plus, manganese 6 plus more electronegativity. Next, compared to iron 2 plus, iron 3 plus having more electronegativity. For example, negative charge answer O minus 2 less than O minus 1. Okay, because negative charge inversely proportional to electronegativity. So these are the examples. Okay. Then electronegativity directly proportional to bond energy. First of all, what is bond energy? Bond energy means the energy required to breaking of bond. Bond energy means the energy required for breakdown of the bond. So here more electronegative means more attractions. More attractions means more energy required to break down the bond. That's why electronegativity directly proportional to bond energy. Examples: HF bond energy more than HCl greater than HBr greater than HI. So HF, HCl, HBr, HI. Because fluorine more electronegative than chlorine. Chlorine more electronegative than bromine. Bromine more electronegative than iodine. So electronegativity more means more attractions. More attractions means more energy required to break down the bonds. That's why electronegativity directly proportional to bond energy. Then so here electronegativity we have find out by one scale, that is Skomaker and Stevenson scale. Skomaker and Stevenson scale. In this Xb, electronegativity of B. Here Xa means electronegativity of A. Here Xb means electronegativity of B. Electronegativity of A and electronegativity of B. Okay, this is the formula. So this formula is Shoemaker and Stevenson formula. For example, by using this formula, we have to do a simple sum. If fluorine bond length is 1.44 angstroms, hydrogen bond length is 0.74. Okay, find out distance of HF. Find out distance of HF. Here fluorine electronegativity 4.0 already know. Exam they didn't give us. Minimum values we should know. Sometimes given, sometimes not given. Hydrogen electronegativity 2.1. Then here bond length means distance. That's why radius of fluorine equal to 1.44 by 2 equal to 0.77. Radius of hydrogen equal to 0.74 by 2 equal to 0.37. Now we substitute distance of HF equal to RF plus R hydrogen minus 0.09 mole fraction of fluorine, electronegativity of fluorine minus electronegativity of hydrogen. Now distance of hydrogen to fluorine equal to fluorine radius how much amma? 0.77 plus hydrogen 0.37 minus 0.09. Fluorine electronegativity 4.0 minus hydrogen electronegativity 2.1 equal to answer come. So easy. This is Shoemaker and Stevenson formula. By using electronegativity values, we can find out distance of molecules. This is Shoemaker-Stevenson formula. Then next one, Mulliken scale. Right. Mulliken scale. XM, electronegativity of Mulliken. X means electronegativity. M means Mulliken. Electronegativity of Mulliken. XM equal to ionization energy plus electron affinity by 2. This is the Mulliken scale formula. Mulliken scale. Next to Pauling scale. Electronegativity of Pauling. X means electronegativity. X means electronegativity. P means Pauling. So electronegativity of Pauling equal to ionization energy ionization energy plus electron affinity, electron affinity, electron affinity by 5.6. Okay, divided by 5.6. This is Pauling scale. Here X means electronegativity. Here X for electronegativity. Okay, then if we combine Mulliken and Pauling scale, if we combine Mulliken and Pauling scale, Mulliken and Pauling scale combine. Okay, important one. Mulliken and Pauling scale combine. Right. XP, Pauling scale of electronegativity equal to Mulliken scale. XM means Mulliken scale of electronegativity. XP, Pauling scale of electronegativity equal to XM, Mulliken scale of electronegativity by 2. Okay, by 2. Next formula. Pauling scale for electronegativity in kilocalories per mole. Kilocalories per mole. Pauling scale for electronegativity in kilocalories per mole. That means Pauling scale equal to ionization energy plus electron affinity. Ionization energy plus electron affinity by 2 into 65. Okay, in kilocalories per mole, this formula we have to using Pauling scale for electronegativity in kilocalories per mole. Before all are electron volts. Before these are electron volts. These are in electron volts per atom. Electron volts per atom. So before formula we used for electron volts per atom. This is kilocalories per mole. Kilocalories per mole, that one. Next, this is the scales, Mulliken and Pauling scale. This is Pauling scale for electronegativity in kilocalories per mole. Then another application, by using electronegativity, we have to determination of metallic nature and non-metallic nature. So here non-metallic compounds has more electronegative character than metallic compounds has less electronegative property, because metallic substances always ready to, they can lose off electrons. That's why they having less electronegativity. Non-metallic compounds always ready to gain of the electrons. That's why they having always more electronegativity. That's why electronegativity directly proportional to non-metallic character, non-metallic nature, and inversely proportional to metallic nature. Inversely proportional to metallic nature. This is the electronegativity directly proportional to non-metallic nature, inversely proportional to metallic nature. That's why example, fluorine, chlorine, bromine, oxygen, nitrogen, phosphorus, sulfur, non-metals. That's why these are having more electronegativity. These are having more electronegativity. That's why in periods from left to right, electronegativity increases. Because in periods from left to right, metallic character decreases, non-metallic character increases. Okay, this is another application about electronegativity. Next one, electronegativity directly proportional to S character. Directly proportional to S character. Electronegativity directly proportional to S character. That's why S character, where is more SP? S character, SP having 50%, SP2 having 33.3%, SP3 having 25%. That's why electronegativity order SP greater than SP2 greater than SP3. That means SP hybridization compounds more electronegative than SP2 hybridization compounds. SP2 hybridization compounds more electronegative than SP3 hybridization compounds. Okay, so some examples. For example, acetylene. So CH triple bond CH, acetylene, SP. Ethylene, CH double bond CH2, SP2. Next, methane or ethane, SP3. So acetylene more electronegative than ethylene. Ethylene more electronegative than ethane. That's why electronegative order, this one. Acetylene more electronegative than ethylene. Ethylene more electronegative than ethane. So important point, electronegativity directly proportional to S percentage of character. That's why SP hybridized substance more electronegative than SP2 hybridized substance. SP2 hybridized substance more electronegative than SP3 hybridized substances. Okay, this is another concept for S character. So simply, electronegativity directly proportional to non-metallic nature. Electronegativity directly proportional to S character. Electronegativity directly proportional to bond energy. Electronegativity directly proportional to positive charge substances. These are the applications of electronegativity. Scales also we have already read. Shoemaker-Stevenson scale we reading, then Pauling scale we reading, Mulligan scale we reading, Mulligan plus Pauling scale we reading. Next, Pauling scale in kilocalories per mole also we have reading. So this is about the electronegativity. Okay, till now all properties we have reading. So electronegativity, electron affinity, ionization energy. These three properties directly proportional to nucleus charge. Next, ionic radius or atomic radius inversely proportional to nucleus charge. That's why here electronegativity directly proportional atomic radius opposite to electronegativity, atomic radius opposite to electron affinity, atomic radius opposite to ionization energy, atomic radius opposite to nucleus charge. These four are same property, same relation, directly proportional. These four inversely proportional to atomic radius. Because this stable idea means general concepts you can easily understand. How does periods groups variation? Okay, how does trends is change? You can easily understand. Okay, then what is difference between electronegativity and electron affinity? Difference between electronegativity and electron affinity. Important here. Electronegativity means it can able to attract the electron itself. This is attract to the electrons. Here electron added to the neutral gas atom or neutral gas. Enough, neutral gas. Next, electron negativity, no units. This is important point, very important point. Electronegativity, no units. Electron affinity has units. The units are electron volts per atom, or kilojoules per mole, or kilocalories per mole. So electron affinity has units. Electronegativity, no units. Theoretical questions come up. Okay, next. In electronegativity, no energy release. Here energy has release. This is exothermic process. This is always enthalpy equal to negative. So definitions not need amma. Important one. Electronegativity, no units, but electron affinity has units. That is electron volts per atom, kilojoules per mole, and kilocalories per mole. Here energy does not release. Here energy has release. This is exothermic product. Enthalpy equal to negative. Okay, these are the difference between electronegative and electron affinity. Okay, but classification elements chapter is over. In this chapter, first you focus on learn the periodic table. Each group, each period, you should rate each element atomic number. You should knowing each element electronic configuration. You should knowing means easily you can understand further inorganic. Okay, then you have read one by one trends. How does atomic radius variation in periods and group? Okay, how many types of atomic radius? How does ionization energy variation? How many types of ionization energy? Electron affinity, electronegativity, Mulliken scale, Pauling scale, Shoemaker and Stevenson formula. I given now. So all are practice, including nomenclature. Nomenclature I given how to write nomenclature. Then in textbook or inside the book they given even elements also. For example, 112 what element, 108 what element. So each one you should reading, because periodic table chapter is first of all very basic chapter for further inorganic chemistry. One thing, then NEET exam from periodic table chapter minimum 2 questions coming, sometimes 3-4 questions also coming. These all questions related to further inorganic P block elements. That's why if you thorough the inorganic means, this is big weightage chapter, first one. Second one, it is very basic concept, basic chapter for further inorganic concepts. Okay, so that's why NCERT book, in reference books also should practice more questions. I will also send assignments, and from my videos each point write down and prepare well. Okay, thank you students, thank you.